Okay. Good morning, all. Coming to the next chapter, that is in the second module or second part, that is data collection, storage, and computing using a cloud platform. Okay, so now you all are aware what is cloud platform. Okay, but before that, actually, we will see what are the some of the conventional method of data collection. Okay, now actually, see, we are studying a scenario where, okay, IoT, Internet of Things, that is connecting many devices, using many protocols, all those we have seen. Now, while connecting many devices, these data which has to be transmitted from one device to another device, okay, or it has to be stored someplace, it has to be computed at some place. Okay, how it is done, whether it is done at the collection center itself, or it is passed on to the like DBMS, and there it is computed. Okay, there are different techniques or different methods to do that. So earlier we had saving device data at the local server. This is one of the type. The wherever the data is been collected, okay, it may be a sensor or mobile or whatever it is, there only it is stored. Saving device data at the local server, saving device data in files locally on removable media, SD card or computer hard disk, in that way. Got it? So you know the difference now. Okay, now computer hard disk is not the device to collect the data. Okay, but it is locally available over there for that particular device to store the data. Next one is saving device data uh, and results of results of communication in a dedicated data store. Okay, so you are having a dedicated data storage place. Okay, there you are saving the data. Next, saving device data at a local node, which is a part of distributed DBMS. Okay, so uh, now distributed DBMS will be there. So your data is stored, okay, at the local node of the distributed DBMS. Next, saving device data at a remote node in a distributed DBMS. Okay. Next is saving device data at a data store in a web or enterprise server. So these are some of the earlier conventional type of storage of data. Okay, so now actually coming to the next one, that is cloud computing. So actually, what is cloud computing? It is a new generation method for data collection, storage, and computing. So it means a collection of services available over the internet also. So cloud delivers the computational functionality if requires. If only data is required, data can be transmitted. If resource have to be shared, okay, resource can be shared. So depending on the requirement, okay, or the request, so the cloud accordingly it gives the service. Okay, so cloud computing deploys infrastructure of a cloud service provider. Okay, so the infrastructure deploys on a utility or grid computing or web service environment. So like these are the various types. Okay, how actually you are connected to the web. That is cloud computing is you are connecting it to the web. So how are you connecting? Whether computation itself is done at the cloud web, or only data is being taken from the web, okay, or the storage is done at the web. So that depends. Application is run at the web, so accordingly it is done. Now see, for the user, they need not know like how it is stored or how the application is run at the cloud. Okay, it is not necessary. Actually, in the processor, okay, yeah, like in the computer, how the processor is run, that we are not knowing it. So similarly here, the data, how it is stored, okay, like how the computation is done in the cloud, that we need not know to become a like to take the service from the cloud. Only if that service is available at the cloud, then you can access it. Okay, so only that is sufficient. How it runs is like whether it requires any, no, that is not our uh, business actually. Okay, next, while studying about the cloud computing, okay, now see here, the new paradigm uses XaaS at the internet, that is everything as a service. Everything as a service at the internet, connected clouds for collection, storage, and computing. These three at a time need not happen, any one, okay, or all. Now, some of the key points is we need to know, okay, while studying about the cloud computing. In that, the first one is the resource. Now, resource refers to one that can be read, written, okay, or executed or processed. Now, actually, what is resource? A path specification is also a resource. If you are able to give me the path to that data location, then that is also a resource. The resource is atomic, that is, it cannot be further divisible. Okay, which is usable during the computation. A resource may have multiple paths or just a single path. Okay, the data point, pointer, okay, object, data store, or method can also be a resource. So now system resource means it refers to an operating system, memory, network, server, software, or application. Okay, next, coming to environment. Okay, it refers to an environment for programming, program execution, or both. This actually, those who are doing, like you need a environment to run the programs, okay, when you are using IoT. So that is the same thing here. For example, Windows environment for programming and execution of application, Google App Engine environment for creation and execution of web applications, okay, in Python or Java. So these are the environment. Okay, like which environment similarly we use another term, okay, frequently, that is platform. So platform denotes a basic hardware, okay, operating system and network. It is used for software applications or services over which programs can be run or developed. So platform may provide a browser and APIs which can be used as a base on which other applications can be run or developed. Okay, so I think platform is quite a direct one, which many of you all are aware of it by now only. Next, coming to edge computing. So this is important. Okay, edge computing. So what is edge computing? Now, like it all depends on where your computation takes place. Edge computing, if now see your sensors, okay, or nodes are connected to the uh, cloud, connected to the web. Now where actually the uh, computation takes place, okay, any procedure takes place, that is called as edge computation. That is actually, if whether it takes place at the cloud, or is it taking place at the uh, remote end. If it is taking place at the remote end, okay, then it is called edge computing. It's a type of computing that pushes the frontier of computing applications, data, and services away from centralized nodes to IoT data generating nodes. That means at logical extremes of the network. That's what I said. Here actually in edge computing, the datas or the relevant like requirements are sent to the edges, that is to the nodes or to the sensors. There the computation is being performed. Okay, usually your idea would be, yeah, most of the cases, okay, if the like if that all depends on the again the energy consumption at the edge node also. Okay, if the at the edge, if the sensors are very feeble, then edge computation is not possible. But like most of the cases, people go for edge computation because edge computation because uh, like computation as well as the result, and upon which the application becomes faster and easier. Okay, if at all you have to take any decision, then edge computation becomes easier compared to your cloud computation. So again it has certain constraints, but edge computation is the one which is like mostly used now, provided you design the power management well. Okay, now IoT device nodes are pushed by events, triggers, alerts. Okay, that means what? The control is at the cloud. The control of the computation is at the cloud. The cloud manages the show, but the computation is done at the remote uh, area. Okay. Now, pushing the computations from centralized nodes enables usage of resources at device nodes, which could be a requirement in case of low power lossy network. Okay, the processing can also be classified as edge computing at local cloud, grid, or mesh computing. Now, again, the type of computation is there that we will study next. So, in that, actually, again, we have local cloud. So, there also edge computation can be done. Okay, next, distributed computing. This is computing and usage of resources which are distinguished at multiple computing environments over the internet. So that is distributed. Okay, it is not like centralized. A part of the computation is done, maybe. Okay, this is just an example. Part of the computation may be done at the remote edge, then part at the local web, part at the sub that regional web, then the main control at the main cloud. So in this way also it can be done. So that is called as distributed computing. Here the resources are logically related, which means communicating among themselves using message passing and transparency concepts, and are cooperating with each other. Okay, these are actually location independent. Next, coming to service. It is a software which provides the capabilities and logically grouped and encapsulated functionalities. This service is called by an application or utilizing the capabilities. Like this, many of you know, a service has to be called as and when it is required. A service has a description and discovery method. Okay, through which actually the user will get to know the service. The service binds to service level agreement, okay, between service provider and endpoint. So endpoint is nothing but the application. The service can also use another service. Now see, so many times when you do, some services are provided to you, some services are like denied to you. So that depends on which type of agreement you have done with the main web. So depending on that, service is being like it can be called. Okay, when you call, it can be given or it can be given to you or it can be denied. So that is the service. Next, coming to web service. In that only service only we have web service. Okay, then yeah, service oriented architecture. what is actually web computing? Web computing refers to computing using resources at computing environment of web servers or web services over the internet. So it is very direct. If you use the resources from the web, then it is web computing. What is grid computing? It refers to the computing using the pooled interconnected grid of computing resources and environments in place of web servers. Okay, it is like a pooled interconnected grid. One can access the resource, okay, of the other. Utility, next is utility computing. This refers to computing using focus on service levels with optimum amount of resources allotted when required and takes the help of pooled resources and environments for hosting application. The applications utilize the services. Okay, this is utility service. Now actually this is the interconnecting. Utility computing is the interconnecting one. Uh, this can take the resource from the web computing. It can take the service from the grid computing. Then it can perform the given task. Then when it is the task is done, then it can be given back to the web computing as well as the grid. Okay, next okay, next is cloud computing. Cloud computing refers to computing using a collection of services available over the internet that deliver computational functionality on the infrastructure of the service provider for connected systems and enables distributed grid and utility computing. So grid and utility computing comes here. Okay, here in the cloud computing, at the edge side, that is at the remote side, we don't have to do anything. It is like only the service is we are seeking the service. Okay, and the service, the resource, everything is done at the cloud, and then only the result is sent to the remote nodes. Next is a key performance indicator. Okay, what is this KPI? It refers to a set of values, usually consisting of one or more raw monitored values, including minimum, maximum, average, okay, depending on the scale. So it is like when the sensor some values are taken or it is stored, which is the minimum, okay, what is the average, maximum, like this. A service is expected to be fast, reliable, and secure. Now, depending on the KPI, that is the key performance indicator, quality of service, okay, characteristics such as bandwidth availability, okay, data backup capacity, okay, peak and average workload handling capacity, uh, like if any demand has come, ability to handle that demand. Okay, when I say demand, it is the wavelength demand, okay, frequency, that is a wavelength demand only at different time of the day, and the ability to deliver, like deliver the requested service. All these are calculated based on our KPI, okay, key performance indicator. That is why the to keep a track of KPI is very important. Next is what is localization? Localization means cloud computing uh, content usage is monitored by determining localization of the QoS level and KPI. Okay, so that is actually you're controlling. You continuously you will be getting the KPI as the data. I mean, you get the data. So based on that, KPI is calculated, and if any variation is there from the regulated one, then it can be localized. Next, coming to elasticity. Okay, it denotes uh, an application can deploy local as well as remote applications or services and release them after the application usage. So that is actually, it has to be compatible. The user incurs the cost as per the usages and KPIs. Now see, like every service we can't say it is um, it is like elastic in nature, that is it is compatible to work in any environment. Okay, but if you go for the cloud, okay, most of the applications you find that it is compatible to work. Next, measurability is something which can be measured for controlling and monitoring, and it also enables report of the delivery of resource and services. Okay, next, what do we have? uh, Resilient computing. Okay, what is resilient computing? Now, like we have come across this many times when we run any application or this thing. Okay, just check here. It is the ability of offering and maintaining the accepted QoS and KPIs in presence of the identified challenges, defined and appropriate resilience metrics, and protecting the service. Now the challenges may be big or small. Okay, like it can be for example, misconfiguration. If any misconfiguration is there, usually what do you get? A pop-up window will come. So now, based on the user's requirement, however you do, either you give continue or you give uh, like or you ask it to quit. So based on that, if you give continue, then actually it has to set, okay, it has to make itself compatible to the their available environment. So that is actually resilient computing. uh, every time, like every application, I don't say that it is like resilient computing ability is high, but okay, most of the uh, resilient computing ability becomes good if you go for a cloud computing. That's all I can say. Okay, if you use cloud computing, then resilient computing ability becomes good, because okay, it has to it is directly connected, the service controlling everything is connected to the cloud. So whatever like issue comes, it will get transferred there, and there actually it has a enormous resources. It can take the help of the resource, then it can troubleshoot and it can be sent back. So resilient computing becomes easier. Next comes scalability. Okay, so it refers to the ability using which an application can deploy smaller local resources as well as remotely distributed servers and resources, and then increase or decrease the usage, okay, depending on the scale. So that is scalability. Everybody can understand. Like your whatever the resource what you request may not be fit in to the remote node. So however the cloud, okay, however the cloud like sees the remote node, accordingly the resource can be allocated. Next is maintainability. It is the capacity of storage applications, computing infrastructure services, okay, data centers and servers, maintaining ability, which are responsibilities of the remotely connected cloud services with no cost to the user. Next is XaaS. That time only I said cloud Okay, computing works on XaaS, that is everything as a service. This is a software architecture concept that enables deployment and development of applications and offers services using web. A computing paradigm is to integrate complex applications and services. Next, multi-tenant. Now, what is multi-tenant? Uh, this refers to accessibility to a cloud platform and computing environment by multiple users at a time who pay as per the agreed QoS. Okay, which are defined at separate environment with each other. Resource pooling is done by the users, but each users pay separately. Okay, so actually here multi-tenant means one big DBMS. Okay, in that many resources are there, many users are requesting at that particular time. Okay, still it can be given. Okay, resource can be shared among the users. Further, now one user has some data in it. Now another user through the cloud, okay, it can request for this particular resource from this particular user and use it, okay, for its application. And once the application is done, the connection will be lost. So this is actually multi-tenant. Okay, so that was about the different terminologies which we used in the cloud computing. Now coming to coming to the diagram. Okay, here you can see devices or sensor network data collection at a device local server. Okay, see here we have device, okay, or sensor network. Many device or sensor network is there. Okay, now here coordinating nodes are there to collect the data. Okay, you can store the data at the local files. Okay, or you have a distributed database node. This we have studied what is like a distributed database. It is like for small number of sensor devices. Okay, a distributed database node will be there. This has the ability to compute, okay, then send the result either to the sensor or it can be sent to the internet. Okay, similarly here if you uh, see this is actually collecting the data. Now this is the data center server. See, this is a database firewall. From here again it is connected to the internet. Okay, here also we have distributed database nodes. Okay, now these are the data which is being collected at the other end. So this can be sent to this. Okay, this can be sent to this. So this is IoT or M2M local data collection plus storage at this end. This is storage of the applications and services at this end. Okay, it is connected via internet. Okay, next coming to cloud deployment types. Okay, cloud deployment types, we have three main categories. Okay, how and all it can be deployed. This one is public cloud. Okay, first one is a public cloud. This is the public in the sense that it's entirely not yours. Okay, anybody can use that. It is provisioned by educational institutions, industries, government institutions, okay, or businesses or enterprises, okay, or even it is open for the public use. Next one is the private cloud. Now, this model is private or it is also called as the community cloud. Okay, this model is exclusive for the use by the institution, industries, business. Okay, and it is meant purely for the private in the organization by the employees or any associated users only. Okay, next coming to hybrid, the name itself tells. Okay, you will have uh, like inside your organization some cpu, some computing power, some memory in one or multiple data centers. Okay, and that will make the private cloud. Additionally, you can give the data or get the data, okay, from the public cloud. That is also possible. Like every information, every data of the institution need not be given out. Okay, so few datas are exclusively for the internal use. Okay, few datas are given or few datas are taken from the public cloud. That then such network becomes hybrid cloud. So this was about the deployment models, cloud deployment models. Okay, now advantages of cloud computing. Okay, now like essential features. Okay, advantages are it is on demand self service to users for the provision of storage, computing servers, software delivery and server time. Okay, now you can have a resource pooling in multi tenant model. Okay, because as just now as I said, from one user, if any data is there, that can be accessed by the other user. Okay, broad network accessibility in virtualized environment will be there. Then elasticity. Okay, massive scale availability, then maintainability. Okay, then interconnectivity platform with virtualized environment for enterprises and provisioning of in between service level agreement, that is also there. Resilient computing, as I have explained. Okay, then advanced security and like moreover it is a low cost because you don't have the headache of storing the data at your place. Okay, for any resource, you don't have you don't have to think about storing the data. Okay, you can access it. Now what and all are the uh, concerns of the cloud computing are requirement of a constant high speed internet connection. If internet connection is there, then cloud computing is not possible, that everybody can make out. Limitations of the services available. Okay, though we say that resources can be shared, then how much it can be shared, if at all it has to be shared, okay, in which basis it has to be shared, then actually then develops the complexity in the computation, so that becomes the limitation. Then possibility of the data loss, that is also there. Okay, data loss can happen. Non-delivery as per defined that is service level agreement specified performance. As per the agreement, the uh, what is that, the function may not take place. Next, different apis and protocols used at different clouds. Yeah, you need to have again either a gateway. Okay, because in different cloud different protocols are used. To interconnect those, you need to have gateway. Then security in multi-tenant environment needs high trust and low risk. Correct. So since the you're giving the access to the other user, so what all it has to be accessed, either it is only data or any other information. How to hide the other information when one user is using your data? So all those security issues have to be addressed. Then loss of users control. Okay, so as I said, in security only loss of users control it is. Okay, once you give the access for the another user, then actually you don't have the this thing. So this was about the application. Next, in tomorrow's class we will study about service and cloud service models. Okay, so thank you.